Okay, so I'll be going over number 7 on the target round. So compute the number of positive integers n less than or equal to 50, for which n squared minus 1 has exactly 4 positive divisors. So the first thing we can notice is we can factor this as n plus 1 times n minus 1, since it's a difference of squares. So since we have 2 of the factors of this number, and then the other 2 factors would just be 1. So let's just list out. So we already know 4 of the factors. It would be 1, n minus 1, n plus 1, and n squared minus 1. So the only way a number can have 4 positive divisors is if it's the product of 2 prime numbers. So that means that n plus 1 and n minus 1 both have to be primes. So, or it can be a cube of a number. So both are prime, or n squared minus 1 is a prime cubed. So, okay, so let's first look at the case where n squared minus 1 is some prime cubed. So if n squared minus 1 is equal to a prime cubed, let's call that prime p, then that would mean that n plus 1 would be n p squared, and n minus 1 would have to be p. And so you can find that when n equals equals p squared, and that equals p. So if you have 2 numbers that are 2 apart and one is the square of the other, so p would have to be 2, and that means n equals 3. So that's one of the cases. So when n equals 3, we have n minus 1 is equal to 2, and n plus 1 is 4, which is 2 squared. So n squared minus 1 is 8, and that has 4 positive divisors. And then the other case is where they're both primes. So if we need 2 primes that are different by 1, that's what it's called, like a twin prime. So some of those be, so let's see, 3 and 5 are 2 apart, so that means n equals 4 would work. And then 5 and 7 are 2 apart, so n equals 6 would work. So these are all the values of n that work. And for larger primes, we only need to check when n is a multiple of 6, since if it wasn't a multiple of 2 or 3, then one of n plus 1 or n minus 1 wouldn't be prime, since it's either a multiple of 3 or even. So next, let's check 12. So if n is 12, that means 11 and 13, both those are prime, so that works. And then, so let's check n equals 18. 17 and 19 are both prime, so that works. Then n equals 24, that doesn't work since 25 isn't prime. 30 works since 29 and 30 are both primes. And then 36 doesn't work since 35 isn't prime. And 42 works since 41 and 43 are primes. And then 48 doesn't work since 49 is not prime. So we have listed out all the values of n less than or equal to 50 that work. So that'd be 1, 2, 3, 4, 5, 6, 7. So there's 7 possible values of n, such that n squared minus 1 has exactly 4 positive divisors. So our answer is 7.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.